So there are 11 different basic integration rules that we're going to look at. Before we look at those integration rules, we're going to look at some quick tricks for antiderivatives. Keep in mind that all of the basic integration rules are listed on page 250 in your textbook. So you can always refer to that in case you lose track of your notes. So, if I have the integral of capital F prime of x dx, that's going to be capital F of x plus c. Basically, this is saying find the antiderivative of the derivative. Just gets you back to the function that you should have had in the first place, the antiderivative. Don't forget the constant of integration, though. The derivative of an integral, essentially, they're inverse operations of one another, so you end up with just the integrand, f of x, little f of x. So the derivative of an integral is the integrand. The antiderivative of a derivative is the antiderivative. All right, let's take a look at property number 1. The antiderivative of 0. The derivative of what would be 0? The derivative of a constant would be 0. Therefore, the antiderivative of 0 would be a constant. This is just plain old capital C. There's nothing to add or subtract here because the derivative of some constant, plain old C, would give me 0. Property number 2. The antiderivative of a constant K would be K times the variable, in this case Kx because it was dx, plus C. So think about it as if it had been the integral of 4 dx. According to this rule, the antiderivative would be 4x plus c. Now, if I say find the derivative of 4x, you're going to tell me that it's 4, which is what the integrand was, so that checks out. And then the derivative of the plus c, that's a plain old constant. The derivative of a constant is 0, so I do in fact get the integrand, which was plain old k. The next property, number 3, is if you have the integral of a constant times a function. Similar to our rules with limits and derivatives, we can factor the constant out in front. So we get k integral of little f of x dx. And then I would need to find the antiderivative from there. But it's important to know that constants can be factored out in front if they're in your way. Let's take a look at property number 4. This one looks very similar to what we've seen before too. If you have to find the integral or the antiderivative of the sum or difference of two separate functions, think of it like a polynomial, and you have multiple terms. You can find the antiderivative of one, and then add or subtract, depending on what it says, the antiderivative of the other. One thing I want to point out, when you write your plus c, you don't need to write a plus c after each piece, because one constant plus another constant is still just the same, some constant. So you can just write a plus c at the end after you're completely done. You'll see what I mean when we look at an example later. Number 5 is one of the most important rules for you to know, and that is the antiderivative of a polynomial term. This is the power rule for antiderivatives. So the original power rule for derivatives said you bring the exponent down, you leave the base alone, and then you subtract 1 for the exponent. Now we kind of need to do the opposite of that. So instead of subtracting 1 from the exponent, we're going to add 1 to it. Instead of multiplying by the new exponent, we're going to divide by the new exponent. And then don't forget there will be a plus c at the end for your constant of integration. Again, this is one of the most important antiderivative rules to know. We're going to use it the most often. All right? And you'll see how it works when we do the practice problems in the next video. But you add 1 to the exponent, divide by the new exponent. Let's talk about some antiderivatives of trigonometric functions. The derivative of what thing gave you cosine? Well, the derivative of sine is cosine. So the antiderivative of cosine is sine x plus c. The derivative of what thing gave us sine? Now this is where you need to be careful. This is negative cosine of x plus c. I want you to think about it for a minute. The derivative of cosine was negative sine. So the derivative of negative cosine would be positive sine. So that's why there's a negative in our answer here. The derivative of what thing was secant squared? The derivative of tangent was secant squared. So the antiderivative of secant squared is tangent x. These are the three that we're going to use the most often when it comes to trigonometric functions, but it's important that you know all 6 trig functions. They're basic antiderivatives. So we're going to go through the other 3, but just keep in mind the majority of the problems that we're going to deal with properties 6, 7, and 8, and not so much 9, 10, and 11. Now, the antiderivative of secant x tangent x is secant x plus c. Similar, the antiderivative of cosecant x cotangent x is going to be negative cosecant x plus c. And the last one, the antiderivative of cosecant squared, that's similar to secant squared, but it'll have a negative, and then it's cotangent x plus c. So these are all of our basic antiderivative rules. In the next video, we're going to go through 6 different examples to help you get a feel for how to apply these rules.